Hello everyone, this is Ravindra Gupta. I'm a worldwide go-to-market lead for machine learning modernization based out of New York. And I welcome you to this webinar about using SageMaker Studio for data preparation. SageMaker is an industry-leading platform for end-to-end machine learning workflow management. And today we are going to dive deep with some of the data prep capabilities using SageMaker Studio. I've been joined by Paul Hargis and Antonio Rodriguez, who's going to demonstrate you how you can take advantage of SageMaker Studio to prepare the data for your machine learning models.
Hello, everyone. This is Paul Hargis. I'm an AI/ML specialist, solutions architect with AWS. Today, I'll be running through several examples that will demonstrate how you can do data preparation using SageMaker while using multiple tools, including Elastic MapReduce or EMR, as well as accessing Delta Lake tables natively.
Hello, everyone, and I'm Antonio Rodriguez. I work as AI/ML Specialist Solutions Architect, and I'm going to be showing also some demos, in this case, how to use Delta Sharing Library from SageMaker Studio, and also how to use SageMaker Data Wrangler for low-code, no-code preparation. So now let's go to the slides.
Okay, so let's dive deep. Data lake have become the norm in the industry for storing critical business data. The primary rationale for a data lake is to store all kinds of data: raw, pre-processed, post-processed, structured, unstructured, synthetic data. So all you can store without first need to structure or transform it. And once the data is in data lake, you need a control access for many different types of analytics and machine learning processes in order to guide better decision-making process. SageMaker is the tool which we have built, and it has one of the most comprehensive offering in the industry with a set of purpose-built tools to solve these complex business challenges. So in next 1 hour, we are going to walk you through the SageMaker Studio capability in data preparation and how you can achieve your business outcome faster using machine learning. So let's just set the stage where we think that machine learning is today and where the industry trends, what we see. So first, machine learning is critical to building modern businesses. This is a core belief that we had over the decade when we part of Amazon.com and over the years in AWS, which we are seeing to materialized. In fact, the business are investing at a much faster clip with a compound annual growth rate of 26% in machine learning. Number of customer, what we see is moving rapidly from piloting to production. So they were trying it out. They were seeing the value of machine learning, understanding what it could bring based on the data, what they have. And now they are realizing those values to move by moving into productions. And third, with the help of explosion of data, research to find new algorithms, open source tooling, and the cloud, these all are contributing to an ecosystem where the real world tasks are easier to handle thanks to this entire infrastructure. And finally, ML is getting integrated into mainstream IT DevOps process. So as becomes its complex, and customer wants the agility in their business decision-making process, they want to make sure that they have a similar to what they're used to do in a CI/CD world, that ML process is being integrated in that. All that said, it is important to note that many companies continue to struggle in their ML projects. That's what we see when we engage them because of the discrete or the third-party vendors or number of stitched together components to build this end-to-end. And that's where the SageMaker Studio IDE becomes a very handy tool for you. So we talked about the data. Data is pivotal for your machine learning models, and your model is going to be as good as what the data is. And that could be seen into this picture. If you think about how where the data fits into this overall machine learning model. It's from start to finish. You need to source data from multiple sources, which is, could be sitting in data lake, it could be sitting in different silo of data warehousing. And then once the data brings in, you need the verification, validation, and exception handling to make sure that data is being ready for machine learning models. One of the challenge which we see in large organization is that interpretation of data becomes quite different from one part of the organizations to another. And that's where the feature engineering becomes extremely helpful for our customers to define what that common taxonomy would look like, and that could be used across the organization. The data journey does not end once the model is being tested and hyper-tuned. In fact, it continues throughout the life cycle. So once the data is in, our customer wants to make sure that they are looking for bias, they are looking for access controls, which is extremely important, especially the regulated industry like financial services and life science, and making sure that they are providing that insight or the decision-making process explainability to different parties as requested. This has been proved by a number of surveys, and one of such survey was by Forbes, and they reached out to data scientists where they said they up to 80% of the work is data prep. Training the data, cleansing, organizing, collecting those data sets, and maintaining and refining for algorithm is becoming quite tedious task. And that's where SageMaker Studio becomes a very handy tool, which provides that IDE where you don't need to go out and build out a separate tool. That IDE can do pretty much what you're looking for your machine learning models right there while you are building your algorithms. So AWS SageMaker offers a broadest choice of data prep services, which you can take advantage of. So if you are coming from an analytics world and you have kind of used to be a Glue ecosystem, you can pretty much integrate SageMaker with the Glue ecosystem to catalog and transform data using Glue Data Brew or Glue Notebook. SageMaker Studio Notebook, which is our unified notebook-centric experience, is super powerful. It can help you to easily discover and connect to data and analytics sources such as Amazon EMR, Redshift, Athena, or Glue Data Catalog. And it gives you the ability to centrally administration data access control, so which is one of the key requirements for a number of regulated industry. So you can centralize that through the data governance tools such as AWS Lake Formation. So in this next session, I'll hand over to my colleague, Paul. He's going to dive deep about SageMaker Studio Notebook capability and how you can take advantage of it for your machine learning models.
Hello, everyone. This is Paul again. So let's walk through the first of the examples. And the example I'm going to show you is how to connect SageMaker Studio to an EMR cluster. So EMR stands for Elastic MapReduce, and it's essentially a Hadoop/Spark infrastructure. Let's and this example we'll share in the artifacts for the webinar. Just to scroll down and show you the overview of the architecture. So SageMaker Studio runs as a managed service on your behalf. You create what's called a studio domain, and we'll be connecting to and creating an EMR cluster, and we'll be connecting through a VPC, which is a virtual private network. So we'll be walking you through these components. Here I am at the AWS console, which should look familiar to most of you. Now, the first thing that happens is that your DevOps or MLOps people will create something in the service catalog. So the SageMaker product portfolio is something that is created on behalf of your data scientists. It's not something that they have to deal with. What you'll see here are, within the product portfolio, there's a SageMaker Studio domain. This is created automatically through a CloudFormation template. The service catalog also includes some constraints and a role. So you'll see this SageMaker execution role when we get started. This is the role that provides permissions for the data scientist when they're interacting with the data sets and the notebooks. So as I mentioned, CloudFormation is actually utilized to create this infrastructure. And here we're seeing the CloudFormation template. If we click over here and look at the resources, we'll see that there's a long list of resources that have been created on our behalf. These include, as I said, the VPC and the various security gateways and endpoints, as well as SageMaker Studio instance. So let's walk over to SageMaker Studio, which is this is the SageMaker Studio view. The first couple of things I'm going to do is show you the navigation tabs over here. So if you've used Studio, you're familiar with the File Browser tab on the left-hand side here. And this launcher page is what comes up if you don't have any other screens open. It's sort of the one stop that you can launch all the various different components that SageMaker Studio provides for you. What I'm going to do though is I'm going to come down here to the component pull down. I'm going to click here, and then I'm going to do this, show this pull down, which is how we get to various components within SageMaker, including Data Wrangler, Feature Store, pipelines, etc. What I'm going to do here is, though, I'm going to come down to the clusters pull down, and first what I'm going to do is view the clusters that are available. Okay, so when we click View Clusters, we're now going to look at all of the running EMR clusters. So remember I said EMR is the Elastic MapReduce functionality. That's where Spark is running in a multi-node cluster. So let me just quickly hop up to the EMR console as well. And so like we'll see, like if we look at all clusters, we can see that some of these are terminated. Right now we have 2 live clusters, or what we call active clusters. And so here we are, this is the EMR console view. We can learn various things about these clusters, like the node sizes, what sort of instance that they're running on, how long they've been up and running. We can even deep dive and look at the monitoring, the hardware, the configuration for these items. And from this page, we can also get to things like the Spark History Server, which we'll look at in a minute. Okay, so this is the EMR console. So coming back to Studio, in order to connect SageMaker Studio to the EMR cluster, we can use Create Cluster here. And you notice that we have a template already loaded and ready. This is the SageMaker Studio domain template. And in this situation, I chose the one that's going to use no auth connectivity to EMR. If you've worked with EMR or Spark clusters in the past, you can have multiple authentication schemes. For instance, you could use Kerberos, you could use LDAP. For the demo today, we're going to use a no auth connectivity. So I've already created my cluster a couple of minutes ago, so I don't have to recreate it. And you see that you see 2 clusters. Now, just for information purposes, I created this initial EMR cluster from a CloudFormation template that was had nothing to do with SageMaker. So I can see not only clusters that I create, but I can see other clusters that I have access to. So I see both of them out here. Now what I'm going to do is I'm going to be connecting to this one, which is the Studio EMR cluster that I created right here within Studio. Okay, so let's look at the notebook that I've created today. Okay, so this notebook is going to walk us through how to connect. So the first thing that we do is, in order to connect, we can click on the EMR cluster that we'd like to connect to. We do that here, and we click on the Connect button. We can choose between basic auth and no credentials. I'm going to choose no credentials. And what we have is we're automatically executing this connect through this magic command here. We're connecting to the cluster. All right, so here we are in the Studio notebook, and the first thing that we do is we connect. So when we click on Cluster Connect, we get this code is automatically dumped into the notebook, and we are connected over the Livy interface, the network interface, to the EMR cluster. Now, next thing we can do is we can look and see that we have our Spark session object, and we notice that we have a Spark context available as well. So this has been auto-created for us. Anything that starts with the magic command %% local will run locally. Anything that does not start with that will be submitted to the Spark cluster. First thing we can look at is we can do info command to see that our cluster is alive. We'll scroll down and start to analyze the data. So we do have this EMR cluster was provisioned with a single database. So we're going to query that database right now using Spark SQL. And we see that there is a movie reviews table out there. I'm going to move pretty fast through these cells one by one. We see that using, again, Spark SQL, we're going to do a select command on here and get access to the table data. Now, remember, all of these commands, unless they start with local, are executing on the remote EMR cluster and running the Spark commands that we have typed in here. So first of all, we see that the sentiment, there's a sentiment column, and it has 25,000 instances positive, 25,000 negative. So we're able to load that here, and we're able to even present a graph using matplotlib. You can see that they're equally divided among positive and negative. We can do things like evaluate the length of the review. This would be the number of characters in the review itself. And notice here with this SQL-O, we're able to pull data back from the Spark cluster to our local notebook memory. So I've asked for it to load just 1,000 rows. So we just brought back 1,000 rows from the table, and we now have it's locally resident in our memory here. Let me scroll past the summary. We see it's 1,000 rows long. We can do a quick look at the shape. It's 1,000 rows by 2 columns. And we can continue to interoperate on the data. Now, the logs data, we can also query over the Livy session. We can look at our logs that's running. These are the Spark logs that are being collected on the EMR cluster. And I've already run the rest of this notebook for the demo purposes, where we run a processing job, followed by a training job, and followed by a deployment. So I want to point out this send to Spark command. We can send variable data right over to the EMR cluster. So we send the bucket name, we send the key name, and we're ready to process. Now, I've already trained a model here, and I have deployed it. So let's see if we can scroll down to, we've deployed it right here to an endpoint. And well, let's submit another live review. This is just by typing in the text here of the review. Let's go ahead and submit it to the endpoint, and we see that we got a negative verdict or a label against this particular review that was seemed to be highly negative. So that wraps up the first of the demos. Okay, in the second example, we're going to demonstrate another solution which was demonstrated in this blog, which again will be provided with the artifacts for the webinar. So in this solution, I'm going to walk you through how to interact with a Delta Lake table directly from SageMaker Studio. But I want to point out that for this demo, I've already used Databricks to create a Delta format table, and we'll be loading some of this data right here as shown in S3. So I'm going to go into the Studio IDE and walk you through how we can interact directly with Delta Lake data. So I've done these first cells. I've already executed them, but we have to install some prerequisites. We're going to install a Java package using the conda install, and then we're going to use pip install to install 2 libraries that are required for Delta Lake. So first, we're going to install PySpark, and next we're going to install a Delta Spark library version 1.1 here. So I've got that installed. I'm ready to go. So let's keep moving forward in the notebook. So the next thing I have to do is create a Spark session object. I'm going to do this by adding some additional libraries. We see the IO Delta library, which is where the Delta core library exists. And we're also going to need an Apache Hadoop library in order to interact correctly with S3 on AWS. Now, this Spark context, I want to point out a couple lines here. You'll see that there's some specific things to Delta Spark that have to be configured. So there's a couple of SQL extensions and a catalog extension. These parameters are required, and this notebook is available out on GitHub, so you can locate it and rerun it yourself. So what we find out right away is we've got Spark version 3.2 up and running, ready to go. And we've got some lending club data, some data available through an open source license, just has some loan data. We're going to put that out on S3. So let's take, this is a very large data set, but we're going to take a single CSV file that's part of that data set, upload it to S3. So it's going to sit out here in this. You notice that the Delta demo area that I showed you before. So we're going to go down here, and this is where this data exists. So we have the raw data here, loans CSV, loans Parquet. We can see that this data file exists out here, 2.6 meg. All right, let's go back to the notebook. All right, so the first thing that I'm going to do after uploading to S3 is I'm going to read it back in using Spark. So we do a Spark read.csv. We're interacting. We're using that Hadoop library to interact with through the S3A protocol. So the S3A protocol is adds additional Hadoop library functionality to the S3 library itself. We see that only took 8 seconds to load the data. Take a quick look at the data types for the loans data that we're interested in. And here we do a quick show of just what the data looks like. So we have things like loan amount, funded amount, etc. Now, the next thing I'm going to do is, remember, I've already loaded the Delta Spark library. So I'm able to write out Delta format tables by simply telling it to run or write a format, Delta format here. So this will be writing out in Delta format, and it should go back to here. There will be a Delta demo table here, and there will also be the Delta format that's being written out right there. So that's already completed. We can use SQL to interact and pull from this Delta format table. Let's keep going. Now, the next thing that we can do is use a Delta Table API. So Delta Table is the primary class that's used to interact with Delta tables, and we can use the for-path method to locate the table. We can pull history from it right away. So we see that there's multiple versions. We're on version 13 right now with a new version, with a new timestamp just a few seconds ago. So we're already, interacting with Delta table that we created right here in the notebook. Next thing we can do is we can read it back in, and we can demonstrate schema evolution. So schema evolution means that we can change the column data. We can add additional columns if we want to the pre-existing schema, which was a set of columns, about 6 columns that had to do with loans. So let's go ahead and add 2 more columns. So we're going to add columns that indicate funding type and excess interest rate. So these are going to be the names of the new columns. First, we add them to our data frame. So we have this data frame sitting here. And so using the with column command, we're updating the data frame that's local to our notebook. So now we see that they have some default values that aren't very interesting. They're all sort of hard-coded. But we're going to use this merge schema option to evolve the schema of the underlying Delta table. So let's go check and make sure that that got updated. So we use Delta table again, the static methods, and we look at the history, and we see that a new version exists, and we had some overwrite operations. And so now what we're going to do is use the update method to write to those new columns, and that will verify that we're able to utilize the new schema. Okay, so we're going to do a show, and now you see we've overwritten the funding type in the loan status. The funding type now has actual data in it. So let's go ahead and run the submit an excess interest rate function, which is a Python function. And now using this update command, we're able to actually write to these new columns, fully demonstrating that we have modified the schema and evolved it. So now we see excess interest rate has the new data. You can see that it's actually this current interest rate minus 10, so 13.99 minus 10 is 3.99. That's the new data that's been written to the table. So we can still see the updates, and we can collect history on those updates. So that summarizes the second scenario that I want to show today. All right, in the last sample that I'm going to show you today, we're going to show another way to interact with Delta Lake table data right here in SageMaker. This one is a classic notebook, so I'm outside of Studio. But again, we're interacting with a Delta Lake table format. Now, I've already run a couple of these cells, and so what we're going to do here is we're going to start with this raw CSV file. So I've uploaded that to S3. If we can come out here and look for it, we see that under Spark pre-processing, come down to the input raw loan data, and here's our file just uploaded a few minutes ago. Now, in this example, I've written a PySpark script that interacts directly with this underlying table data. So I want to walk through a little bit of the code here. We're installing PySpark functions directly. We're importing directly from PySpark library. And we can create, also notice here we're creating a specific Spark session object. And here we're designating critical things to the execution of Spark. So we're allocating executor memory of 2 gigabytes. We're allocating driver memory of 4 gigabytes. And we're specifically requesting 8 executor cores. So that's the worker nodes that are actually going to get the work done. You notice some convenience methods in here. We're operating from a partition data set. So we created the Delta table using partitions. We're going to be able to extract files from what's called a manifest. And we're going to also then read Parquet with Spark. So what we do here is we're using Spark to read the underlying Parquet format files, but we're also resurrecting the partition back into a usable attribute. And then the last thing is we're going to accumulate these columns together and do a what's called a reduce. So we've had a partition data set, and we're using a reduce library to combine them all back into one homogeneous data set. Now, so this is the actual code. You see the Python main function here. We're going to use a bucket and a prefix that's passed in as arguments, so that this is it can be reused based on the location of your Delta table data. We are going to be able to walk through the manifest files one by one, pull them apart, and go get the underlying. So the manifest file will simply point to where the Parquet files live. And we'll do some final stats when we run it. So this is what's called script mode, or bring your own script. In this case, it's PySpark. And we're going to be able to submit that to what's called through a PySpark processor, which is SageMaker provides a couple of different types of processors. There's a scikit-learn processor, and there's a PySpark processor. There's also a framework processor for your use. So in this case, we're going to use the PySpark processor because that's what the script is. And you'll notice, like, here we are in the main code, just allocating. We're going to instantiate the PySpark processor with a couple of parameters. We tell it, for example, what size instance type we want to run. In this case, we're using an M5 4x large. And then we do the .run command to pass the final parameters. So because this took a few minutes to run, I had already run it, and this is the output. You see that this Spark job by this name has already run. Okay, so this job has executed, so we can go out and look for it. We can look for the job that executed by going to the SageMaker dashboard. We can pull up processing jobs, and we can look for this particular job, and we find it right here. And so this is the job that just ran. We can see that it has the M5 4x large instance type that we requested. And we can pass in things like the bucket name and the key prefix. These are the parameters that were passed into the script. And if we want to, we can also hop out and look at the logs. So I've already opened that screen. We can go out here to CloudWatch, and we can look for output that we wrote out, including this reading Parquet file, which is a print statement that I put in there. And you can see as we scroll through that it's read, dozens and dozens of files, and under various. This is the partition, so we're using the state name as the partition. If we scroll quickly, we can see that it goes through lots of different states, and in fact, all 50 states of the US are here. So, but we see we've been reading Parquet files as part of our job, and this is the actual location of the file. So that demonstrates how you can actually ingest Delta Lake data and run it directly in SageMaker, and use a PySpark processing job to do the pre-processing that is a prerequisite for doing model training. So that summarizes the third sample today. Thanks very much.
Okay, so now let's see another demo. In this case, extending a little bit on the example that Paul was showing. I'm also going to show you a demo by using SageMaker Studio. So once again, we are in the SageMaker dashboard screen. So I'm opening here my studio environment. And the first thing I want to show you is actually one of the notebooks that we're going to publish very soon for extending the SageMaker examples that we have for the feature store. So in this case, as you saw before with the demo of Paul, he was actually connecting to the Delta Lake directly by establishing a Spark session. So the good thing about that is that you can directly interact with the data that you have in the data table, and you can get a full copy of whatever query you do for the data in memory. And then you are relying directly on AWS IAM roles for handling the permissions and access to the data. Now, there is another possibility for connecting to Delta Lakes, which is using the Delta Sharing client and the Delta Sharing library. If you're not familiar with Delta Sharing, you can go and check it out in delta.io/sharing. So Delta Sharing is basically an open standard for secure data sharing, and it's pretty much supported for integration with different vendors and different types of software. So this can be implemented either in the open source version or even in the commercial version through Databricks. So the difference basically with the other method is like by using Delta Sharing, you can basically rely on tokens that are centrally managed in what they call a Delta Sharing server. So the Delta Sharing server can be installed anywhere in your environment. And that basically allows to have read-only access and short-lived URLs for accessing the data that you need on that data table. So that pretty much simplifies the access because all you need to do is installing a single library that is called Data Sharing. And that will allow you to connect through the client by using that temporary token that you get for reading the information. So just for the purposes of showing how that is done, let me just scroll here very quickly to an example that we have in this notebook. What we are doing in this case is that we are directly getting a profile file from the GitHub repository of Delta.io, where they have an example of how these the open datasets.share file will look like. And if we download that, let's say, public key that they are allowing for these kind of demos, all we have to do is pretty much receive this bidder token. And with that token, we can actually establish the connection and we can start reading to our table. So I'm just pointing to where is the data that I want to read from. And in this case, I'm passing the profile file and then specifying what is the database and the table that I want to read. So in example, I'm going to get one of the sample datasets that they have in the Boston housing dataset here. By just specifying that and pretty much establishing the sharing client, as you saw before with the sample profile file, we can directly load this data as either pandas or Spark data frames. And directly we have this data in memory. So we can do whatever we need with that. So in example, here I'm loading that data as a pandas data frame. And then we can do whatever we need in our notebook for preparing that data. Obviously, this is an example with one of the data sets that was there, but you can imagine that you can extrapolate this example to any customer scenario that you have in your own environment. Now, another cool thing about this is that that will also allow us to establish connections for automating the preparation that we have in the data. So before we have been seeing interactive data preparation, which means that the user has to somehow use the notebooks and the commands to get a response and then run another command and then get another response and so on. But you can also automate those steps for thinking on pipelines that where you can pretty much do everything reusable, and you can use those artifacts in an MLOps fashion. So for doing that, just as Paul showed in the last demo before, we can rely on SageMaker processing. SageMaker processing allows us to run this script, whatever we pass as an entry point for running the preparation and the data. So in the same way that we saw before, the way to establish that connection, we can also rely on Delta sharing in SageMaker processing. So once again, what I'm going to do here is that I'm going to define a processing job. And for that, what I would like to do, as you see in the diagram, is establishing the connection, pulling the data from the Delta table, and then writing into the SageMaker feature store. If you're not familiar with the feature store, you can check it out in our website. But basically, the idea is to have a way to manage the different features that you could have in your tables, which we call feature groups. And in that way, you have a full control, visibility, administration of all of the features that you have. And you can centralize these, or you can share these across different teams. You can have audit on these features and so on. You can add lineage and so on. So in this example, we are pretty much creating a feature group in the SageMaker feature store that I'm going to be calling Boston Housing. And then I load some definition of the features that we are going to have in this sample data set so that we know what is the type of data that can be expected for each one of those. I simply create the feature group that I have just described there. And then from that point on, we can list it and we can see that we effectively have a feature group that is active and is in service and ready for receive information. So now the next step we are going to do is that we are going to use a framework processor. Remember that Paul said before that we can have a scikit-learn processor in SageMaker, we can have a Spark processor in SageMaker, and we can also have a framework processor, which means that you are pretty much defining your own version of whatever you're going to pass here. You can use deep learning, you can use known frameworks such as scikit-learn, etc. Now, the advantage of using a framework processor in this case is that once again allow us to pass some requirements or dependencies that are needed to be installed. So in this particular example, what I'm going to do is that I am passing a code folder in this case that is going to have the requirement that I need, which is the Delta sharing library that we are going to need for establishing the connection, and the Boto3 library from AWS that will allow us to interact with the feature store for writing the results of the processing job. Now, the other thing that we are going to pass also is an entry point. So apart from the requirements file that I pass, I can also pass a pre-processing script, just in the same way that Paul showed before, where we have all the code of whatever transformation we want to do. So let's analyze a little bit this script that we have here, and starting with importing some libraries, one of them being delta sharing that we just installed as a dependency. We can also define how we are going to set up that connection to the Delta sharing library, to the Delta table that we have in this case. So for that purpose, we are pretty much including the sharing client as part of the processing script that we have here. And then we are passing as a parameter what is the profile file that we want and what is the table that we want, which are simply arguments that I'm going to pass dynamically whenever I call this processing job. So as you can see, we are pretty much loading the data from the table as a pandas data frame within the processing container that SageMaker is going to instantiate for me. So not using anything in my notebook, but actually doing in a managed fashion the processing job. And then I can do some transformation. So for this dummy example, I'm dropping some duplicates here and dropping an ace, and also doing some split on the bin count and so on using NumPy, etc., etc. You can do any type of transformation here that you need for your data. And finally, I have the step of writing the results to the SageMaker feature group that we defined before. So for that, we are once again relying on both to tree and directly writing into the ingesting into the feature store that we have. And for that, I have this function ingest to feature store, which is defined over here. And as you can see, all we are doing is establishing a client with the SageMaker feature store runtime. And then we are using the put record command that allows us to write the records that I have in my transform dataset to the feature group. Now, if you run these, obviously you are going to have to run the command, the processor that we just defined by using the run command, and passes any arguments. So in this case, it is our code folder, our source tier, so that it reads the requirements, the entry point, and the pre-processing .py that we defined before. And then you also have to specify if you need to copy anything. So in example, I want SageMaker to copy the profile file that I have from S3 and put it inside the container so that it can use it. And then the output data so that it can actually get it, process data and write it to S3. Now, once we run that, you will see that it takes a few minutes, and it will actually run everything that we require here, and then it will tell me ingesting process features into the feature group and so on. We can actually analyze that to make sure that we have that data in our feature group, so we can actually describe the features that we have in the feature group, reading it, and making sure that we have the data there. We can actually query the feature store for making sure that we have the records there. So I'm taking a random customer ID here and getting the record to make sure that I have the data. And I can actually take multiple records also and query in batch so that I can make sure that I have all the data there. Obviously, from this point on, you could be doing other things. Like an example, you could use the data that you have now in the feature store for training your models, right? So either in the offline or the online feature store that is created, you could be using that for triggering a training job in SageMaker and then hosting that model or things like that. So that's pretty much one of the examples we wanted to show you. And finally, for closing this webinar, we also have a trend now of customers who are actually doing data preparation by using low-code or no-code tools. So if you're familiar with our Amazon SageMaker Data Wrangler feature, Data Wrangler allows you to do precisely that. So you can actually do the preparation in a very interactive and intuitive way by using low-code or no-code. How do you start with the data wrangler? Is very simple. So basically, you can either start a new data flow directly from the SageMaker Studio launcher here, or you can go to the data wrangler tab in the SageMaker resources, and then you trigger a new flow. Whatever way you start, I'm going to open one that I have here pre-created because just for saving some time. And it will tell you pretty much what is the source data that you need. And if you start creating a job, you will see the different sources supported right now, which includes S3, includes Athena, Redshift, and even third parties such as Snowflake and Databricks by using JDBC. And in this case, I'm going to load one of the sample data sets that Data Wrangler already provides for us. So if you want to play around with the feature, you can actually use one of the sample data sets that it includes, like the Titanic data set. And in this case, I can start adding some steps. So for every point, you can actually add transformations, add analysis, train a model, get data insights, add destinations, or export as you wish. So in this case, we can, in example, add an analysis for data types. And the first thing that you will see is what is the table that I'm importing here in that sample data set, or whatever data set I'm integrating with Data Wrangler 2. And then we can override any of the data types that we see. So if we see that is there any column, any particular feature that is not reading the proper, detecting the proper type here, we can override. Now, the next thing that we can do is that there is a very nice feature that is called data quality and insights. And actually, just by saying here that you want to get data insights, you can actually trigger a job that looks like this, where you can actually define what is the type of analysis you want to do, what is the target column that you have in your data set. In example, I have the survived column here in this classification data set. You can specify the type of problem, etc. And then when you trigger create, what Data Wrangler will do for you is that it will analyze the whole data set and it will give you some recommendations for data preparation. So in example, it will give you some summary of statistics. So how many features you have, rows, missing values, how many are having valid values, duplicate rows in your features, and so on. How many different types of values you have in each one of the features. If you have any high priority warnings in your data, it will also flag it so that you can take an action. And then it will start doing some analysis in things like anomalies. So what is the anomaly score that you have for each one of the features, and what are those records that are having a high anomaly compared to the rest of the records in the data set. With regards to the target column, it will also show you how many classes you have, how many of them are valid. You can also have some quick modeling doing with a small sampling of the data, so that we can actually train, in example, the classification by using XGBoost, and you see how good is your data for training a model based on that sample. For that model, you also have here more metrics like precision, recall of one score, the confusion matrix also if you want to check false positive, false negatives, and so on. And then for each one of the features, you will have a summary of statistics, details, graphs, distribution, etc. Now, the nice thing is that Data Wrangler is also going to give you some recommendations. Like an example, here is telling me that there is a recommendation on a feature that is called Boat that has 9 categories, which are these, which could be leading to overfitting. So they are pretty much recommending here to consider consolidation into a single category by using the transformation that is built in called replace rare values. So you can look for that transformation as part of the handle outliers option, and then find and replace the substring, and so on. So it is already telling you what to do for improving the quality of the data if you want to look for that kind of recommendations. And then you have the full analysis, as I said, for each one of the features here, and graphs, and so on. So let's go back to our data flow that we saw before. And the next thing that I'm going to do is that we can also add some analysis in the way of graphics. So we can actually add histograms, bias reports by using SageMaker Clarify, feature correlation for getting shapely values, scatter plots, table summaries, and so on. An example, I could be having a histogram of how many survives based on age, and then I could be having this kind of visualizations added as part of the work that I'm doing in the data preparation. Finally, obviously, we are interested on doing transformations. So Data Wrangler already provides more than 300 transformations that are built in. An example here, we are going to be inputting missing values. So if we add a step at any point, you will see a full menu of options for each one of the categories that you see here. So, in example, if you want to handle missing values, you could be using transformations like, in example, imputing or field missing, drop missing, and so on. And then how you want to do that exactly. So in this case, we are doing an imputation for missing values. We could also be adding custom transformations. So if the more than 300 steps that you see, transformations that you see there building are not good enough for you, those ones, by the way, are the most popular that we saw normally in the data science field for specifically for machine learning. But if those are not good enough for your case, you can also define custom transformations. Actually, you can do it using PySpark, Pandas, Python code, or even SQL for doing that. So in example here, I'm using PySpark basically for adding a row ID for each one of the records that I have here. And I'm going to call that column passenger ID. And if you go here to the data set, you can see how the column is added. And then it's adding a sequence of numbers as I wanted to do here in this rolling window. And then I could also rename columns, etc., etc. Now, finally, the last step is where do you want to write the results of this? So in this case, I'm going to be sending the results to two possible destinations. So the first one is actually a feature group. So if you decide to go to a feature group, you can even create the feature group directly from this wizard. So if I do it now, it will take me to another window, and it will allow me to create a feature group like this one. That is pretty much going to have all of the features that I have in that data set. For each one of them, I can see the details, metadata that I want to define. I can even edit the metadata for add some parameters, in example, to which department this data, this column or this feature belongs to, or if I want to do any type of description to the whole data set and so on. So I can actually be very granular on what is it that I want to add there. And it even gives us some sample queries already, so we can use Athena, so we can use SQL for doing things like time travel, remove tombstone, removing duplicates, and so on towards our feature store. And then we can even add new features, delete the feature group, and so on. Now, the other destination that I'm defining is S3. The results of this transformation is also going to write a data set to S3. So those obviously are the options that I chose, but you can pretty much do whatever you want with your flow. Finally, you can either run this job directly as it is right now, so that SageMaker is going to do all of this pipeline of transformations for me for data preparation. Or I can simply export these into different formats. The first format is I can be creating a Jupyter notebook, in example, that is already having all of the commands that I just did here. Or I can even export a Python script that is directly having these transformations. Or I could be sending this directly to SageMaker pipeline. So it's actually going to create a Jupyter notebook already with the steps for putting this data preparation pipeline into a SageMaker pipeline ready for MLOps. Or I could be also sending to the feature store by using a Jupyter notebook in a programmatic way. Let's assume that I want to run this job right here. So what I can do is just click on create job. It will suggest some name that I can put to that processing job that is going to trigger. And what is it that I want to include? I can add some configuration. Example, let's say I just want a single instance. What is the type of instance that I have? The volume size, anything that I want to specify here. And I just click on run, and it will pretty much create the processing job for me. So let's do a little bit of the magic of the kitchen here, because obviously the processing job takes a few minutes. Actually, I can see here the processing job that is running. And a few minutes ago, I ran another one that took 6 minutes and already gave me the results. So I can go directly to my S3 and I can check that here is the data of the feature store. In this case, feature store is going to index automatically the data by using a timestamp. And then it's going to tell me where are those files that are being stored there. Feature store automatically stores everything in Parquet format, so we can see that automatically they're indexed and automatically split also in the proper way for efficiency. And then I have also the export, the result that we gave in the destination S3, and that is simply written as a CSV because that's the way that I wanted the data to be out from the data preparation workflow that we showed before. So with that, we have seen two ways of doing data preparation. And again, it all depends on what are your needs and what are you looking for and what is the proper way to establish those integrations. But you have many possibilities right now by using SageMaker and the whole set of features that are behind SageMaker and the SageMaker Studio IDE. Okay, so thank you for watching. And once again, please join our Tech Talks, and thank you for being here with us during the whole demos.